The Cone Penetration Test, or CPT, is an advanced technology which characterizes the soil beneath the Earth, better compared to the conventional geotechnical investigation methods such as standard penetration test. It works by hydraulically pushing an electronic steel probe into the Earth's surface. With this, we can measure the tip resistance, friction resistance, and pore water pressure. These parameters are useful to determine the geostratigraphy, soil types, pore pressure, and engineering properties of the ground. Here at GPI, our cone penetration test follows the ASTM D5778 standard test method for electronic friction cone and piezo cone penetration testing of soils. It revolves around three key components: the cone, the anchor system, and the hydraulic pusher. The procedure starts by positioning the hydraulic pushing equipment plumb and level on the site, may it be on land or offshore, both of which are offered here at GPI. A pusher is then stabilized via anchoring or addition of weight to the pushing equipment. This is to prevent the uplifting of the pusher when the cone penetrates the soils. This pushing equipment then operates at a speed of 2 centimeters per second, and attached to it are the push rods threaded with the cable connection. Then, found at the end of the push rods and connected to the cable is the assembled cone electronic penetrometer. Cones have standardized sizes of 10 or 15 square centimeters with a standard cone angle of 60 degrees. Each of them have their ideal diameters and height of cones. This cone is loaded with sensors at the tip, surface area, and base to measure the tip resistance, the sleeve friction resistance, and the pore water pressure respectively at each corresponding depth measured by the depth transducer. These data are transferred real-time to a data logger connected to the laptop. Here, the site engineer sees the preliminary results in real time. Once the data gathering is completed, the following can be identified. First, the geostratigraphic profiling is seen. The soil layers and their fundamental characteristics can be interpreted. Second, its soil behavior classification is identified with the help of empirical charts. Lastly, soil parameters are obtained which are useful in the engineering design, such as in foundation designs, settlement predictions, and embankment profiling. Pretty convenient, right? Though it is important to note that there are limitations to be considered when using CPT. One of those is the inability to retrieve soil samples for laboratory testing. Additionally, CPT can only exert a maximum amount of force depending on the cone size used, thus limiting penetration in very hard soil layers. Lastly, CPT is inapplicable to gravelly soils or soils with boulders and roots, as they can potentially damage the cone. In summary, CPT offers a fast, effective, and efficient site investigation alternative compared to its conventional methods. It is accurate and reliable with the ability to provide real-time and continuous data during testing that can be used to determine the geostratigraphy, soil types, pore pressure, and engineering properties of the ground. To learn more about the cone penetration test service offered by GPI, you can contact us at geophil.com/contact us. Don't let the surface appearance of the Earth mislead you. Let GPI unearth the facts.